Hello everybody and welcome to assignment V. We're on the second page, page 214. We're dealing with equilateral triangles. Find x for numbers 1 through 6. So we're going to use the properties of equilateral triangles to help us find that. For number 1 here, it only tells us one angle, but due to these markings I know that this angle is equilateral. So all these angles will be the same, 6x, 6x, and 6x. If I add them up, I can set them equal to 180. 6x, 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 18x. Divide by 18, x is 10. Alright, for our next one, angles are the same. Equiangular implies equilateral. So all these sides are the same. I can in fact set 6x minus 5 equal to 5x. I'm going to subtract 5x from both sides and get x. I'm going to add 5 to both sides and get 5. X is 5. For number 3, I know that 3x is this angle right here. I'm telling you that we tell you that KLM, the big triangle, is equilateral. So this segment right here is acting as a bisector. 3x is on this side and 3x is on the other side. Okay, and since it's equilateral, I know that it's equiangular. So each angle must add up to 60. That means these right here are going to be 60, all of them. 3x plus 3x has to add up to 60. 3x and 3x make 6x. 6x equal to 60. Divide both sides by 6. X is 10. So you're going to use similar strategies for 4, 5, and 6. Down here on number 7 we have yet another proof. Writing a two-column proof, we're given that triangle ABC, the big one, is equilateral, and angle 1 is congruent to angle 2. So let's start out by writing our given. Triangle ABC is equilateral. If we know it's equilateral, then we know that all the parts, all the sides are congruent. We can say that a segment AB is congruent to segment CB. And we can also say that angle A is congruent to angle C. Now it is possible to say these in two different steps. We'll just be efficient, combine them into one. The reason we know this is because an equilateral triangle has congruent sides and congruent angles. For number 3, we know that angle 1 is congruent to angle 2. That is a given. And then our fourth statement, we have now established triangles being congruent. Triangle ABD is congruent to triangle CBD. How do I know that? The steps up above here, I've established angle, side, angle. That's why I've noted what I've noted. That's what we're trying to go after. We've got to prove those two triangles congruent. The ASA postulate. Now, it gives us to our last step. We're trying to prove that the one angle, ADB, is congruent to the one angle, CDB. And that is from CPCTC. Congruent parts of congruent triangles are congruent.